Pre-algebra lesson 122, permutations. So permutations are the number of possible not combinations. It's the number of possible ways that we can arrange objects in a particular order. So the logical way to understand permutations is simply like this. We have to create a box for how many slots we have to put these objects in. Right? And then in each box we put how many options for objects there are. So let's say, for example, I've got 6 different books that I want to put on the bookshelf, right? So the number of slots I would have would be, well, I'd have as much room as on the bookshelf, but I mean, a normal bookshelf can hold more than 6 books. So the number of slots would definitely be 6. Now, in the first slot, how many options do I have to put up for the first book? Well, if I've got 6 books, then I've got 6 options. Now, after I've put one book up in that slot, I don't have 6 books anymore. I now have 5 books. So in the second slot, how many options do I have to put up for the second book? Now I've got 5 options. Okay, and then so on and so forth. You can see now that I've put 2 books up on the shelf, I've only got 4 options left. So I've got 4 options for the next slot, and then 3 options, and then 2 options, and then 1 option. So to find out the number of combinations, I take the number of slots, the options for each slot, and then I multiply all of these numbers. And that will tell me the answer to how many possible ways I can put 6 books onto a shelf. From here, I can go ahead and use the associative and commutative properties. I'll multiply in whatever order pleases me the most, or makes it most simple for me. So let's see here, 6 times 5, I know that's 30. Let's see here, I know 3 times 2 is 6, 6 times 2, or 6 times 1 is 6. I know that 4 times 6 is 24. And then if I did 24 times 30, okay, that's a little bit of a tough one. We'll do 24 times 30. Bring down the 0. 3 times 4 is 12, 6, and 7. So 720 ways for me to organize 6 books on a shelf. Okay. Now that was an interesting problem because I had just as many slots as I had items. And whenever we have a problem like that, where we have a number multiplied by every single integer or every single whole number all the way down to 1, we can read this as saying 6 factorial, or 6 with an explanation point. So 6 times 5 times 4 times 3 times 2 times 1, that's called 6 factorial. Written like that, factorial. Okay, so that's a mathematical notation that means taking 6 times every number below it. So for example, if I were to write 9 factorial, that would equal 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So that's great. Now what happens if I don't have the same number of slots as I do items? Well, let's say Mary had, well, we'll do example 122.2. Let's say Mary has 8 objects, but she can only take 3 with her to the park, right? So how many objects does Mary have? Well, she's got 8, and then she can only take 3, so that's 3 slots, okay? And they want to know how many different combinations of objects could she take to the park with her, or permutations could she take to the park with her. Well, we would take those 8, we take the slot, the first slot, I've got 8 options there, and then the next slot, since I put 1 there, I've got 7 options, and then the next slot I've got 6 options. So the answer would just be 8 times 7 times 6. Okay, so 8 times 7, that gives me 56. 56 times 6, oh, I've got to multiply that one. Get 36, 30, okay, 336 different permutations of what she could bring to the park with her. Okay, so that's how permutations work. It's pretty simple. Number of slots that you have to put objects in, and then the number of objects that you have, counting down 1 number each slot. If you end up going the full number of slots as you do objects, that's called a factorial. That's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.